Ever pondered the workings of a DC machine? Imagine an intricate dance of electrical currents, magnetic fields, and mechanical components, all perfectly synchronized. This mechanical marvel, the DC machine, is a cornerstone of engineering, yet behind its operation lies a world of complexity. At the heart of this complexity, a process unfolds that breathes life into these machines. It's a process shrouded in intrigue, a process that keeps these systems humming along day in and day out. Well, it all hinges on a pivotal process known as commutation. In essence, commutation is an electrical gymnastics act. It's like a tightrope walker performing a daring feat, except instead of a circus tent, this show is happening inside your DC machine. Let's break it down into simpler terms. Picture a bustling city with cars zipping down the roads. These cars represent electrical current flowing through the armature winding of your DC machine. Now, imagine a roundabout at the heart of this city. This roundabout is your commutator. The role of this commutator or roundabout is to direct the flow of traffic, or in our case, the direction of the current in the armature winding. Just as a roundabout ensures cars can change direction smoothly without causing a traffic jam, the commutator ensures the current changes direction in a seamless manner. It's like a rhythmic dance, perfectly synchronized, ensuring the current flows in the right direction at the right time. This process of changing the direction of the current is what we call commutation. It's a constant back and forth, a continuous reversal of current direction in the armature winding. All of this is orchestrated by the commutator, the maestro conducting this intricate symphony of electrical current. And why is this so important? Well, without this change in direction, the motor of the DC machine would simply stop. The continuous reversal of current keeps the motor spinning, powering your DC machine. So, in layman terms, commutation is the switch that keeps your DC machine running smoothly. Now, you might be wondering how this switch is flicked. Let's shed some light on that. The role of brushes in the commutation process is instrumental. These brushes, though small in size, are mighty in their function. They maintain uninterrupted contact with the commutator, a cylindrical component that rotates in sync with the motor's rotor. These brushes glide over the surface of the commutator, facilitating the flow of current into the rotor's windings. And here's the magic part. As the commutator turns, the brushes switch from one commutator segment to another, effectively reversing the direction of current through the rotor windings. This switching process, that we call commutation, is what keeps the rotor spinning in a constant direction. It's like a well-choreographed dance where the brushes and commutator move in perfect harmony to keep the motor running smoothly. That's right, these tiny brushes are the unsung heroes of your DC machine. Like any hero, brushes too face their nemesis. Commutation isn't always a smooth sail. Here we stumble upon challenges such as spark generation and the wear and tear of brushes. Sparks may sound exciting, but in the world of DC machines, they're a villain. They can cause damage to the commutator and drastically reduce the lifespan of the machine. Now let's talk about the wear and tear of brushes. Constant friction against the commutator takes a toll on the brushes, causing them to wear down over time. This not only affects the efficiency of the machine, but also demands regular maintenance, which can be a bit of a hassle. So how do we tackle these challenges? In modern DC machines, materials like carbon graphite are used to make brushes. They reduce the friction and hence the wear and tear. In addition, methods like resistance commutation and compensating winding are employed to minimize spark generation. Indeed, even the tiniest components have their battles to fight. So, we've unraveled the mystery of commutation, but what should you take away from this? In essence, commutation in DC machines is a pivotal process that enables the conversion of alternating current within the armature into direct current at the terminals. It's the unsung hero, ensuring your DC machine runs smoothly and efficiently. Remember, the commutator plays a crucial role here. Acting as a rotary switch, it reverses the direction of current through the armature coil at the right moments. The brushes, in turn, maintain contact with the commutator, allowing current to flow into and out of the armature. However, it's not always a smooth ride. The challenges of sparking and wear and tear on the brushes can pose hurdles, but with careful design and maintenance, these can be managed effectively. So remember, every time you switch on a DC machine, there's a complex yet fascinating process happening inside, thanks to commutation. And there you have it, the secret behind the smooth operation of your DC machine, the humble process of commutation.